we built a gunshot locator. Our goal was to build a product that is cost efficient and low power consumption device that can accurately detect a location of a gunshot sound and then report it to the user or the essential services so that they can respond on time.
So this is the Arduino, which is the brains of the device. Connected to it through I2S is a microphone with a sample rate of 8,000. This is the charging circuit. It's responsible for charging the Arduino and keeping it powered on. Behind it, you can see that it's connected to a battery and 3 solar panels. The solar panels will keep the battery topped up while the charging circuit can charge the battery and run the Arduino at the same time. You have a simple on and off switch that you can use to turn the device on and off.
So once these 3 URL requests are received from Arduino, all the computations are made in the cloud platform. These requests are combined into one URL request, which is then sent to a triangulation code. Triangulation code computes where the sound came from based on the location of our devices. Finally, all this location is stored in a database. The user can see this location on a web page that the user can access through a text message or text alert that will be sent to the user once the gunshot is fired.
The triangulation code works by receiving the 3 timings from the 3 sensors. It already has the positions of the 3 sensors stored in its memory. It starts by identifying the sensor that detected the sound first based on its earliest timings. It calculates the distances between that sensor recording it and the subsequent sensors recording it by subtracting the timings and multiplying it by the speed of sound. Using those distances, it can construct 2 triangles based on the distance between the sensors and the distance between the hypothetical shot location. It uses these triangles to create 2 law of cosines equations based on the hypothetical side lengths and the angles within the triangle. It uses these law of cosines equations to create a nonlinear system of equations, which it solves using Newton's method. With those side lengths and angles, we can find the angle to the shot and the distance to the shot, which we then use a vector rotation to find the exact location of the shot, and we return it to the rest of the system.
So we have placed 3 Arduinos in 3 different places, and I'm now going to play a gunshot sound, which is going to trigger the Arduinos and initialize the triangulation function. Now let's get a closer look.
This is the satellite view of the 3 sensors that we have located in the quad, and this is the close-up view of where our sensors are located, and in the center we have a speaker that will play the gunshot sound. This is the close-up view of one of our sensors, and if you notice closely on the left there is an LED that should blink whenever it registers a gunshot sound. As you saw, the LEDs got triggered, which means the gunshot was registered. And now, as we can see, the function execution has started, and we're waiting for triangulation to happen before we can receive an address of the gunshot location. The user will receive a text notification through which a user can access a web page where they can easily see the location of the gunshot. The address that the user gets is the nearest landmark to the gunshot location.
The future scope for this project will be to have more thorough testing and add more devices to a wider field area. Apart from that, neural nets can be used to improve the accuracy of gunshot detection.